Thanks for coming to this talk. I'm going to talk about generative application engineering to try and see if we can integrate generative AI with the engineering disciplines in the college. So I pulled this out from last month, the newest hiring trend that CEOs are literally begging to hire students with or anyone with these skills. And this is the CEO of Quora posting on X. A single engineer who will use AI to automate manual work across the company. And this could be any company, like not only a tech company, this would be any engineering discipline, any non-engineering discipline. Yeah. This is where the jobs are. There's another tweet that puts it in a more concise form. Is like the hottest job in the world right now is AI automation engineer. And so there is some truth to that. This is where a lot of the students that have come out of my class, they are getting internships doing this kind of work. So the motivation is that we know that generative AI and LLMs are going to change the way engineering is being practiced or will be practiced. And so as a college, how can we change what we do to best prepare students for this future? And this is a pretty daunting question because it's like a pretty big upheaval in our operations. So the goal, and this is work that I was doing with Amita on an NSF project, is to reimagine engineering for the Gen AI generation. And so the idea is that we need to figure out how we can leverage advances in AI to reliably and efficiently solve engineering problems, because we're not going to be doing all of this stuff manually for much longer. And so we did this for a very specific discipline, and this was for cybersecurity. And so we did this for 2 years, and there is the biggest lesson learned from this. I have 5 others, but I'm only going to talk about one because we moved on here. We gotta be quick here because I want to cover a lot of things. The first and most important thing is that now more than ever, creativity matters, and being able to cultivate that matters. And because we've seen as technology has evolved that the importance of the mechanics of doing something is now being lessened. And so this is a picture of a number grid. My mom gave me a quarter, or no, it was a dime for every sheet that I filled out and gave to her. And this preceded computers, right? So you like, no shortcut here. This is a picture of when I was in like the things that I would do as an undergrad to prepare for an exam. And this preceded the World Wide Web and Google. You were forced to put everything that came at you in a course, write it all down, take it to an exam, and regurgitate that. And I don't think people are doing this anymore, but I don't know. Do you know anyone in engineering who still does that? And so this is no longer necessary anymore because we're like, okay, that's what Google is for. So we don't do this so much. This is what we've been doing, was doing in grad school, been doing and teaching for the past 20 some years. It's like, you got to grind away at the Unix command line. You got to grind away at the programming, VS Code or Vim or whatever you want to do. You got to grind away there. And then generative AI is like, yeah, maybe not so much. You can just natural language process your way to the win. So
progress stopped in 1980?
1980? Oh, is that what that number is?
No, I'm
okay.
Looking at everything there I had used by 1980.
1980? Yeah, well, you get the analogy. So then the question is, what is our value add now? How do we, because if you're going beyond that, what do you do? So that's the question. And we would argue that it's basically creativity and imagination. That you have to get students to practice and nonstop. So fostering creativity, and I'm going to go with a musical exemplar. There is a group that I follow kind of religiously. I kind of know their background, and I know I've been to a lot of their concerts. And I'm going to talk about how they are producing at the highest level. What did they do? And I use this as an analogy of what we should offer our students in our curriculum. So the first thing is that these musicians have to start by learning foundational disciplinary knowledge. There's no getting around the fact that you need to know, for example, music theory. You have to know your chords and your keys, and you have to know a taxonomy of all the different musical genres. And this group combines a lot of these different genres in their music. So that's the foundational disciplinary stuff that they do. And then they have to master the tools of creation. So in this case, they're a rock band. They got guitars, they got drums, they got keyboards, but then they also are mastering the use of orchestral instruments in their performances. They master the washboard as a musical instrument, and then they also play the vacuum cleaner. Sounds like, who does that? And then, so they have all of that. That's their foundation. And then nonstop, they practice creativity. So they were the second group ever to play the Sphere in Las Vegas, and they didn't play a single song twice. This was every single piece that they played 4 shows. Every single, and both the visuals and the actual music that was generated was unique. And they do that because they have practiced creativity and they're super good at it. They are super good at coming up with an idea on the spot and generating the music to do this. And then because this was a part of a security talk, after every security talk, you say you have to somehow profit. That's the idea. You do all this stuff and then you somehow profit. And this particular group profited. And I gave the answer to this last week, but like, does anyone know who this group is here? No? This is Fish. It's a jam band, like the Grateful Dead.
Yeah.
So then the idea that I would suggest that we have to consider as a college is generative application engineering. Can we do the same thing within our disciplines is the idea. So I'm just going to talk about how we did it for security. But anytime you see security content, you replace your domain knowledge or anything that you have thought of for your own discipline, and you substitute that and then think about how to automate these things. So applied to security, what we do is we get students to quickly learn foundational disciplinary knowledge. We don't get them stuck in the details, but they have to know the things that they are working with. So this applies to computing, this applies to security. And then they have to master the tools of creation. In this case, generative AI frameworks and generative AI tools that can be used to produce something. Those are their musical instruments. And then they have to practice creativity. They have to learn how to take all of that knowledge, use the tools to generate something new. So they imagine and build every week of the class that I'm going to talk about. And it's basically a hackathon model with intrinsically motivated programs. So the students come up with what they produce rather than me telling them what to do. And that's the idea. And then at the end, it's profit. And I would say, at least intellectually, I personally have profited from this because I tend to learn more from my students through this process more than any of my students learn for themselves. So I've been lucky enough that I can see what everyone does. And so this is from Mark, our department chair. He loves to use this proverb. And this is what it is. This is distributed learning. And it's really impossible for a single person to keep up with all of the stuff that's going on. So you send students out there, you allow them the autonomy to use whatever tools they want to build their app. And then by watching what they build, you can actually incorporate some of that stuff. So talking about this course. So for this course, they start with foundational disciplinary knowledge. And in computing, there's a whole bunch to teach. There's all of these topics, at least in systems, that you're like computing systems, programming languages, document formats, infrastructure management, API specs. There's like all this stuff that could be automated. And you have to teach them what all of these things are because you put a monkey in front of an LLM and it's not going to generate what you want very efficiently. So you basically have to train the person in front of the LLM to actually produce something that's actually meaningful for someone to use. So that's what we do. And then we also, because of the security, we're trying to apply this to security, we have to actually give them a bunch of foundational stuff, domain-specific tasks that people do in cybersecurity. So there's a range of things that humans are doing now to make cybersecurity, to practice cybersecurity. And then you also want to give them all the different solutions out there right now that can be used to solve all of those different tasks, because you don't want to have the LLM reinvent something that is perfectly fine being done as a tool. And we'll get to this idea of what do you let the LLM produce versus what you allow an LLM to leverage Turns out for some operations, you don't want the LLM to actually generate an exploit. There's plenty of exploits out there. The LLM can decide which one to use. That's fine. But like, you don't want the LLM to actually do something that has already been done perfectly fine at a much cheaper cost, at a much lower energy, much more reliably by a tool. So this is why it's really important that students understand the tools that are out there. So there's no getting around that either. There's a lot of stuff to learn. And so there's some examples of tools. And I put these here because we're going to see how about I have a high school student this summer. He like took in a week and a half, he was able to take these tools and like exploit a server with them. Okay, and then the second piece of this is mastering the tools of creation. And so one of the first things that we do for the first week of this class, and I got this from Amita, sitting in on Amita's class, is like you have to learn how to use LLMs effectively. And most students don't actually. And actually, I would say most people who haven't been using LLMs every day of their sort of haven't integrated it into their workflow in a meaningful way, they're using it suboptimally. And so this is just like the LLM whisperer. You actually have to be an LLM whisperer in order to get what you want out of the LLM. And so and then not only the LLM, it does depend on the LLM you're talking to as well. So you have to know about all the different models and what they have been designed to solve. So for example, there are reasoning models, and then there are models that have been trained with natural language tasks more than reasoning. And then you have to decide, well, I have a reasoning task. I need to use this reasoning model because it makes a difference when I'm trying to do something that's like an agent versus something that's just, write me an essay task, in which case you would use just a general purpose model for that. So I have the ChatGPT, Gemini, Anthropic, and then Llama, which is an open source one. So we teach them all the prompting strategies. So when I mentioned that Innovate Academy, they have everyone do the Prompt Essentials course. That's the idea of taking that course. And every student needs that. Like we have that, and that's effectively the things that I cover in the first week is essentially what's coming out of that Prompt Essentials and the AI Essentials course that I mentioned last week in that Innovate Academy. That's what they're doing. The second piece is building LLM applications. And so there are a lot of frameworks out there that allow you to build an application around the LLM. And so I'm going to talk about LangChain in this particular talk, but there's also Llama Index and there's Haystack, but they're kind of, you got to pick one. And so you have to pick a winner. And so I picked LangChain. I think it's a winner, but who knows? You might have to change this if there's something else that's there. And then so this is for building LLM applications. The other part of this is that you have to be able to use LLMs to build applications. So there's like two things. And so this is where coding agents come in, because then they have to be able to take the LLM to produce the thing in the middle. And that's where really you can get a pretty good lever in the projects that you can get students to build. And then the third part is practice creativity. And so this particular course forces them to build LLM applications, again, to try and solve each one of these tasks that I had talked about initially. And so I just want to go straight to what got produced. So there's just some highlights from the course that was offered. I had a student build a geographic visualization agent where you could just ask the model to get to show an image of the geographic location of all the recent traffic that a particular server has received. And what it would do, it would figure out the network interface that it had available to it. It would call TCP dump, which would collect all the packets. It would call Scapy to parse all the packets. It would call this IP info API to do a reverse lookup to get the geographic location of the sources, and then it would call DALL-E to generate a plot, or it could have called Matplotlib. It could have called any of these other tools. And so by knowing all of these tools, it could be, oh yeah, I can write an agent to utilize this. And this is where the creativity part of it comes in. I had a student build an SSH honeypot where they were like, let's pretend to be a Linux server. And this is meaningful because adversaries are sitting there trying to find juicy targets to basically break into. So if you have an effective honeypot, that looks like a vulnerable Linux server and acts like one and talks like one, you can actually waste their time. And so that was this particular project. And then my favorite one is this pig butchering victim agent to pretend to be a victim in order to expose the operations of a pig butchering scam. So you basically sinkhole these exploits, and then you pretend to be the victim to basically get the wallet addresses and the websites and the apps that the adversaries are trying to use to lure victims to send them a bunch of money. And then you would automatically package that up and like send it to law enforcement. So that's this particular project. And I had a capstone team do this to build this particular thing out. Okay, so that's the first thing. These are LLM applications. There is a week in this class where I don't let students write a single line of code. Like you get the LLM to produce your entire application, and this is what they call vibe coding. It's like you leverage LLMs to build your entire application. You use a chat interface to not only create the code, but to debug and run the code. And so there are these agents, the coding agents. So we use Aider because that preceded, this is before GitHub Copilot and Cursor were a thing. We started with Aider, and then now we have GitHub Copilot and Cursor Labs, because this is the way you can actually produce applications quickly, but you can produce it very poorly if you don't have practice using these tools. And I really think this, like for the computer science folks, like we have to get students practicing this. Otherwise, they're not going to be able to compete because everyone else is practicing this. I know, like, I have friends in industry or former students actually in industry talking about their use of these things. And, there's an estimate. It's like 80 to 90% of the code next year is projected to be generated by AI. So that's the creative using vibe coding to build projects. And so here are some examples of some vibe coded projects. Someone built a OAuth 2 application using Python and Flask. And it was one of the hardest things. Is like I have a whole week of my cloud class where they're building an OAuth application, and this person's like, yeah, I just chat. Like this basically took like 5 or 6 natural language prompts to generate this. And I'm like, oh, I guess I better change that lab. I have a student used Aider to develop a wireless pen testing application. So basically, you bring your agent to a place that has got a bunch of wireless networks, and you say, hey, break into any wireless network that you can. And there's many well-known ways, especially if you're using like WPA2, like you can break into these things. And then like, let me automate that. And this is with Aircrack NG. And then I had another student vibe code network traffic visualization application, similar to the other one, where you get percentages of traffic coming in from particular IP addresses, and then you plot them automatically. And so not a single line of Python code was written by the student. It was all vibe coded. And this is where practice. So what they would do, they would tell me you'd have to rehearse this. You'd have to get experience and figure out what the thing can and cannot do. And then you develop your final script. And that sort of process of figuring out how to communicate to get what you want is super important, because otherwise it's like, without that training, you're not able to get this. So this is actually, you might think this is super easy because you didn't write a line of code, but actually it does take some training on the LLM to figure out what the LLM is going to respond to. Okay, so how do we do this? So I'm going to talk about this course, CS, it's got a regular number now, and give you the blueprint of this course. And if you look at this, you can easily see where you can rip out the security part and put in your own domain-specific stuff in there, and then build a generative course for that kind of activity. So the first week, everybody needs this first week, is you have to figure out all the different tasks and all the different ways to optimize the performance of a model. And so this is where that prompt essential stuff, and all this course material is available if people want to just take the slides and adapt them for their own course. Those are there. So all the different prompt strategies that you would need to use, and you use these prompt strategies and see what you get out of the model, and then use different ones and you see if that worked. So this is the first week of the course. And then the next 2 or 3 weeks of this course is the LLM framework. And we chose to use LangChain because at the time it was the only thing there that was legitimate. But now there's other alternatives. But I still think a lot of people are using LangChain, but it's easy enough to adapt the curriculum to whatever framework people are currently using to build LLM applications. And this is what I'm going to talk about later on. It's all these different parts of LangChain and how easy it is to build an application with them. This is why this company is valued at $1 billion right now, or something like that. Okay, and then because it's a security class, I have to show people all the ways you can exploit an LLM application. It turns out this is a Pandora's box because people who don't know the adversary, who haven't practiced the adversarial mindset, they're building these things and they're just immediately compromisable. And so this is, I have them. So basically, they spend a couple of weeks building their own LLM applications. And then I leave that the I force them to leave a super powerful tool in their LLM application. And then in the fourth week, they realize that a prompt can basically wipe out their entire application because of unintended consequences. And that's this fourth week. This is OWASP's top 10 security vulnerabilities for LLM applications. I really think this should be done in the context of teaching generative applications because students really need to understand that this could be very dangerous what they're doing. It's like, oh yeah, great, I automated all of these tasks, but I can also automate my own sort of like ruin. And that's where this piece comes in. And then this is the part where it's domain specific. So the last half of the course, you're like, hey, I have all these different tasks on the right that cybersecurity people do. I want you to evaluate the performance of LLMs in doing these tasks. And you have the answers. So I give them tasks that have known answers, and they can see, they can actually do a ground truth. Because it's not like generating an essay where you're like, I don't know, it's whatever it is. This is actually, can it actually solve this? And this is where you can sort of see where the model performance and your model, your ability to get what you need out of a model and the ability for the model to give you what you need. You can see where that line is like, well, it's mostly going one direction, but you have to know where the edge is in order to appropriately build an application. So that's why I have them do this. And this is going to continually change the tasks that we have them do based on because you always want to give them a task that the LLM fails at so that they don't think that LLM will solve everything. They just have to know where it is. Okay. And then they just practice. They practice writing these LLM security applications that they come up with. So they have to attempt to do this. So all of these labs are scaffolded. So there's a lot of sort of boilerplate code and examples that I give these students because the best way to learn is to learn by example and then to extend the example. All of these are at this code lab site that I run, and the labs are all backed by a Google Doc, so you could just click on the report of a mistake link, and then you can download the Google Doc if you want to adapt these labs to whatever course that you're offering. Okay, so I want to talk about the thing that I think can be shared across the college, which is the building blocks, the framework that we can all use. And it does require a little bit of programming, but it's not a ton of programming. It's like you could put this in that freshman capstone or the freshman sequence that is being done, really simple examples at least. And I'll show you one that we run in Cyber PDX, like high school kids. And then it's like, yeah, you can explain to them how to use these. In fact, there's be a one-page application that I'll show you that we run in this high school camp.
Really quick question, LangChain in comparison to something like Windsurf. Is Windsurf?
Windsurf's a coding agent, so that's more like Cursor and GitHub Copilot. So that's more like an IDE for generating. So yeah, I thought about adding Windsurf, but some of these things, the licensing is an issue. So for GitHub Copilot, you can get that for free as a PDX.edu. Cursor is a 2-week free trial. And then we only use it for a week. So I'm like, sign up for Cursor. Aider is completely open source. And it's a complete text interface, chatbot interface. So you do it on the command line, not through an IDE. So you just want to show students one example of a thing. And then I would put, yeah, Windsurf if you want on that. Okay, so why did I choose LangChain? It does look like the LangChain was the first mover, and usually the first mover gets the critical mass. And this is where just last week they're like, yeah, it's about $1 billion valuation because they're an AI infrastructure startup and they produced a whole bunch of code and support for rapid development of LLM applications. So that's why I chose LangChain. And so you can think of LangChain as the operating system for LLMs. Like you're using LLM as a tool, but then you have, in order to actually make the tool meaningful, this is not like just, I'm going to interface as with a chatbot. No, you actually want to build stuff around the LLM that's beyond just chat. So it supports rapid prototyping of LLM-powered applications. It's open source. And it's model agnostic in a way that you can, because most of these models support a standard interface, it's called the chat completions interface to interact with them. You can just drop in different models based and then see the performance of your app using different models. And so we can, I can show you examples of that here. So I'm going to go through all of these just very briefly, just to give you an overview of what these abstractions are. I'll talk about model access, chains of operations, and prompt management to begin with. So models, it's just this uniform interface for accessing, being able to query a model and get a result. And so that's what LangChain, they have a particular way of unifying the access. And then prompts. So prompts are basically templates where you fill in this template and then you generate a string, which it ends up being a command to send the LLM to get the result. And so this prompts they consist of a template, a set of and as part of the template, you have a set of system instructions for saying, what are the parameter, or what is the role of this query. So those are the system instructions. And then the query is whatever the user asks for. And then finally, context is what extra information can I bring into it to give the model to produce a better result. So that's the management of all of that is what LangChain supports with its prompt template library. Okay, the next thing they introduce is a concise way of organizing computations that involve an LLM. And their most basic abstraction is chains of computations, like assembly lines. And so you have so for example, the simplest chain is you start with the user input, and then you splice it into a prompt template, and then you pass that to the LM and then pass back the result. So that's the simple one. So then this gives me the ability to teach a high school student the first program to use LangChain. And so this is the question that they were like, do models have occupational gender biases that are inaccurate? So this is kind of a fun exercise. You're like, yeah, I want to know what kind of biases are in the model, both truthful and untruthful. And I'm going to give an occupation and see whether or not a model thinks that occupation is mostly male, mostly female, or is actually correctly representing the Bureau of Labor Statistics. So you have a ground truth. So this is why I use this for high school kids, because it's like, hopefully it resonates with them. So the model support. So you can see, you import the model, and you can instantiate this as LM. And so there's a Google generative AI model, and then you can replace this with the OpenAI model. And then you select within the class of the provider which particular model you're interested in using. And then you have to supply your API key as well. And then here's an example of 2 prompts. And so what we're going to do is we're going to have the LLM generate a whole bunch of stories with this story prompt. And then as part of the story, eventually you're going to use a pronoun. They're going to use a name and they're going to use a pronoun. And then from that, you can say, that's what the story prompt does, generate a 100-word story about a person. Then you have a gender prompt that says, oh, I'm going to take that story and I'm going to figure out the gender of the character in the story. And it should either be male, female, or unknown. And I'm going to just take the output of this story and then generate the gender. And then I have the occupation chain. This is again, the chain that I mentioned earlier, where I take the input, I send it to the story prompt, take the occupation that the user gives, I send it to the story prompt, get it into the LLM to produce the story, and then take the output of the LLM and then send it in as the story input of the gender prompt. And then I pass that into the LLM again to get the gender. And then when I do this, I say occupation chain invoke, and the occupation I'm interested in is a carpenter. And then I figure out male or female. And then I write a loop. I do this 100 times. This is 100 queries, like 200 queries to the LLM, and then produce this result. So here are some examples. This is a Python notebook I have students use to run this. So you're like garbage collector, all male. So then they're like, okay, that's pretty accurate. And then you're like president of the United States. Well, there was one female, and so historically that's not accurate. But you can see there is a biasing going on, and the person who added the bias is the model vendor. And this is the ethical issue. It's like, what do you want the model vendor to do in terms of either inserting or removing bias. Like, do you want ground truth or do you want an aspirational future? And that's the question. It doesn't have a right or wrong answer, but this is exposing that, right? Like you are allowing the model. So for example, like 80% of CEOs are female. So that would be, and then you can actually print out this.
Where's that come from? I saw that as well, like, is
Oh.
that inherent bias in the LLM, and if so, where's the data for that?
Oh, yeah, and so
overcorrecting.
it's overcorrecting. So this is what got Google in trouble because they were generating a whole bunch of historically incorrect ethnicities on historical figures because they had basically a DEI post process or a diversity post process that was like, oh, so then you're like, well, you should know about that, or you should at least have control. You should have control over this, or it should be transparent.
Yeah.
So this is one of the things that Google does is the transparent, that's like fairness, accountability, and transparency. That's what you just need, some transparency for this particular aspect. So this is an interesting exercise. It gets students to think about this. And this is actually, there's the Python notebook I have somewhere in a Google Drive that you could use if you want to teach this to high school kids. This is the mechanism I would have.
Quick question, so do you independently check whether it's assessing gender correctly in the stories?
No, but we ended up looking at the stories. We're like, what? Why is this like? So I just did Grok last week, and so Grok is like as bad as everyone else. It's like we did the president one. It was 10 female, and then it was like Elena Martinez, and then some of them the same name. Different stories every time, but pick the same name and gender every single time. So this is where you don't know what's going on with the model. Like there's a temperature setting. So we didn't modify the temperature setting. The temperature setting allows the model to sort of give you much different results. So we just like, we'll just take the default temperature settings and like, we'll go with that. And so then we're like, yeah, my high school student made me go and get Grok. He's like, look at this graph. Grok is way better at these tasks. You got to go get it. So I gotta get it. And then it's like way worse for the thing he wants to do. So it looks like they tuned the model for the benchmark. And then we were actually trying to use it for our stuff. It like failed. So now we're back to the other models.
So these are all independent queries from scratch? But
Yeah.
Can you also tune that using this tool so that it, if you sometimes you have an ongoing conversation?
Oh, yeah. So then it doesn't get any of this. No. So this chain has no history between the invocations of that chain, but you could attach a history of, so typically what would happen if you did a chatbot, this template would start, you would use this and then you would start attaching the messages of the history of the chat. And then you would send the whole thing into the model so that there was context in there. So these are straight up no memory invocations. But again, so this is the simplest thing. So most students can look at this and like, I understand that, right? Like it doesn't take a rocket scientist. It doesn't take 4 years of an undergraduate CS education to be able to look at that and say, okay, I think I can build one of these.
But this type really is functional. I mean,
Oh yeah.
there's no-
Yeah, there's some like random syntax I left out just for clarity, but like this is the guts of it. This is the guts of the program, and it's in that Python notebook, and they just press play. And then, oh, look, and then they can experiment. They can actually change it. They can change the prompts in there, and then they can just, experiment with the LLM. So, yeah, this is a good exercise. Okay, so the next thing I want to talk about are document loaders and vector stores. And I think this is the real reason that you would keep on using LangChain, because it turns out that last thing on the bottom right, there's better ways of doing agents than LangChain, which I'm going to talk about later. So, but right now, so what are these things? The first thing, so if you recall with prompts, you have a prompt template, you have the instructions, you have the user query, but what about this context? Nothing in that previous example brought in any external context. It was all produced and given to the LLM with no external information. So as it turns out, after training, the LLM can't give you any result that it hasn't been trained with. And so in this case, it's like, oh, tell me about the security elective for the BS in computer science. And it turns out we put that in 2022 is when we put that into our catalog. And at this time, ChatGPT was like, sorry, I can't give you that information. It's 2021. The idea of context is to leverage the fact that LLMs are really good at taking information and summarizing it and giving you an answer based on that information. And this is called in-context learning. And so one approach that you could do to answer that question is take the entire CS website, put it into the user prompt, send that thing together as a context-aware prompt into the language model, and then return a result. And you could do that, except there's a lot on our CS website. Although with the new CS website deployment, I've heard that there's going to be a lot less, which to the consternation of Mark, apparently they're wiping out a whole bunch of the stuff that students actually need.
That needs to be in an internet.
Yeah, but this is terrible. This approach is terrible because this is a super high token cost. So you are paying per token that you send into the LLM, and you're paying per token on the stuff that comes out, and you get poor attention performance. So attention means the LLM is trying to optimize across your entire prompt. It's trying to make you happy. And if you give it too much stuff, it's going to lose its focus. So this is where you get really poor performance out of the model. So the better approach is to somehow produce just the relevant documents that relate to the user query, and then to attach just the relevant documents in a context-aware prompt, send it to the model, produce the result. So this is what retrieval augmented generation is, and this is a figure of it. You have a user give a prompt, and then you pull in context from either a stored database or from the internet. And then that's what you do. You put into the LLM and produce an answer. And this is where the document loaders and the vector stores of LangChain are really useful, because you don't want to have the student have to do all of this work. You want that stuff to be done for you. So this is really where I'm like, okay, LangChain is what you have to teach in order to get this kind of functionality into an LLM application. And I would say every discipline would need this particular component. Okay, so the document loaders and the support for document loaders in LangChain is extensive. So there's a whole bunch of places we can get our documents from. There's a whole bunch of formats we can get our documents in. And LangChain has the ability to do both: retrieve it and then extract the data from it and produce the text. Now, everything goes into the model is mostly text, although you could send it an image or JSON, and then it extracts that information and then allows you to load that into your LLM application. So you have to teach them all of this, or you teach them these things. They have to know what these data sources are and ways of getting the data from it. Okay, the other thing that is essential is if you're going to pull that data and you're going to store it locally, you need a very efficient way of doing a search on it and getting the relevant context out of it. And this is what vector stores are for. So, I'm not an information retrieval person, but the idea is trying to do this information retrieval stuff very easily. And so a vector store is a poor person's like Google search index, I would say. You can think of it as that. And so the idea is in traditional databases, you store data straight up into a traditional database. With a vector database, you also store a vector that basically wraps the semantics of the data somehow, using a model, into a sort of a search space, a vector search space, that allows you to put related documents in similar distance to each other in this search space. So this is documents. What's it?
Oh, going back to Jerry's solve. Yeah.
Yeah. So what you do is you take your documents, you split it up into chunks because you don't want to do the monolithic document in there. And then you send it to an embedding model. And this embedding model is basically like what Google or OpenAI has trained an embedding model to take this information and generate, and usually it's about 1,000 dimension vector that represents the semantic content of that. And it's a floating point vector of 1,000 dimensions. And then you store that vector alongside of the actual data in a vector database. So this is the vector store. It's got the data and it's got this vector store that gives you this n-dimensional sort of vector storage space. And then what happens is when you get a query, so all your documents are in this vector store, you're going to get a query, and it's in yellow, and then you send that query through the same embedding model to see where it shows up in the vector store. And so this shows up right here. You see the yellow dot appear over here. Sorry, it's small. And then the vector store is like, I'm going to get the most relevant documents near that yellow dot, and I'm going to return it. So that's the relevant splits. And this is what you end up putting into the LLM. Okay, so this is what it is in a nutshell. Only the relevant context from the knowledge base should be added to this prompt. So the first step is you create vector embeddings of all the documents in the knowledge base. So basically for the CS chatbot, I scrape the website. I write a crawler, I scrape it, and then I produce for each web page and each split on the web page. I send it to the embedding model, get the vector document embeddings, stick it in the vector database. In this case, I'm using a vector database called Chroma, which I'll show in code. And then what I do is on the chatbot, when a user types in the query, I send the query into the same embedding model, get the prompt embedding, look up the relevant documents in the vector database and have that returned. And then I have the relevant documents with the user prompt. I generate the context-aware prompt, send it to the language model, get the result. And this is a very effective. So this is what's running the Ask CS website. And so when they wipe out our old website, this will be what people will use to get the old stuff until we figure out how to get I don't know what they're going to do. I'm asking Mark to get our domain back, www.cs.pdx.edu, so we can have a shadow website. But I'm going to actually have all this information in a vector database stored so that people can actually get information out of our website. So here is the UI. And so you can go to this site and actually send these queries like which faculty work in AI. And then it'll show you these are the people and the links to their web pages of the people who work in AI. And these are the usual suspects in our department who are potentially going to be running the BS in AI degree if when it gets up and running. So yeah, and this code is available. You can just clone it. You could actually just change computer science to electrical and computer engineering or civil, and then you get your own chatbot for your own department. There's like one thing you have to change. And you actually need a Google API key from me, but I'm happy to give you one.
Different knowledge.
Yeah, and you just deploy it. This is all click to deploy on Cloud Run too. So you do need a Google Cloud project, but like you could just build this. And this is actually an exercise our students do in the cloud class now. Like deploy their own chatbot.
So small question. So something that's augmented query.
Mhm.
So that's a separate kind of interface to the LLM. So
No, you're attaching it before it gets into the LM, and I'll actually show you the code.
so it's all still part of a single query.
Yeah, single query. So here it is. So you have the vector, in this case, the vector database is stored locally on the same container that runs the UI. And then you're like, okay, I'm storing all this data in this, just locally in the file system in this ChromaDB. And then I instantiate a retriever that's going to do this sort of vector lookup based on the input. And then I instantiate the LLM, and this is my prompt template. And this is exactly the one that's running the site. You're like, you're an assistant for question and answering, provide the source. So this is important. It's like, I want you to provide the source URLs of anything that you answer with. And then if you don't know the answer, just say you don't know. Don't make something up. Because, there's the car company that got in trouble for offering their car for $1. You're like, don't make that up. Like, if it's not there on the site for $1, don't say you can give a car out for $1. That doesn't, like, you don't want that. So that's basically what I was like, don't tell a student anything that is not in the context that's in the vector database. This is really important because, they talk about hallucinations. Well, you can engineer your way out of hallucinations, but you have to know how to prompt the model to say, don't make anything up, just say, I don't know. And this is behavior that you have to specify to the model. So we just had this discussion about how important it is that students still need to learn how to specify input, output, and behavior of their code or their algorithm. They got to do this for the model now. Otherwise, you get garbage as a result. So, and then this is the prompt. The question will come from the user, the context will come from the retriever, and then this is the prompt template. So it's super simple. And then there's the RAG chain for it. Context is pulled in from the retriever. The question is taken from the user as a runnable pass-through. You send that to the prompt template, and then that goes to the LLM, and then the LLM produces an answer. Okay. So that's RAG in a nutshell. And I think these are things that I could probably teach this freshmen and sophomores if you give them give them a little bit of Python, and then these abstractions can be taught separately, and you can ramp people up with this content pretty quickly. The next thing I want to talk about are agents, and this is the scary thing. So the prior chains are simple, like a pipeline. It's like, okay, that's innocuous. And then the RAG chain, it's just a simple chain. But there are a lot of applications that the chain is insufficient. You actually need the LLM and the application to iterate in order to produce a result that's useful. And so for that, you have these things called agents, and this is where agentic AI is all sort of like the current thing that's happening. And so what is an agent? So an agent, you take an LLM and you give it some tools, so things that it can use to get stuff done. And then you give it some memory as basically a history of a trace of execution, actually, is basically what this memory is. What have I done? What are the results of previous operations that I've done? And I can use all of that to figure out what I'm going to do next as a tool. And then you take a prompt in from the user, and the LLM is asked to produce to reason about what the prompt is asking for, and to reason about how it would use tools to answer that query. And that's the strategy. And so then the LLM is like, oh, well, if I want to answer this prompt, one of the things I'm going to do is out of these tools, I'm going to figure out an action to take. And I'm going to invoke a tool, get the result, and then I'm going to store this in memory and then reason about where I'm at right now. And then I'm just going to repeat this over and over and over again. Every single step, I'm going to do this over and over again. And eventually, as part of the reasoning, it says you should always stop after every step to see if if the prompt has been answered.
Yeah.
And once you feel like the prompt has been answered, whoops, wrong direction, you stop. So this is what an agent is. And this is what I show high school students. This is where the Terminator scenario is like, yeah, we're a little bit closer to this than we were 5 years ago. So this is what people are talking about. So Godfather of AI is like, yeah, 20% chance of AI killing us. And same with Musk. So everyone's got this 20%. But there are some that are like 99%. And you're like, oh, wow, that's bad. And like we might need to do something about that. And I would say I'm a little bit closer to the 99% because I watch what this Palantir company is doing, and I'm like, yeah, that's not good. But and they're saying that they have to do this because China might be doing this. Like, oh no, this is really not good, because then China is going to develop this because we are for sure developing this for fear. And this is where I'm like, oh yeah. Okay, so I'm going to talk a little bit about levels of agency, because when I teach this class, I have to teach different levels of it. And you'll see that the highest level of agency, it's terrible right now. And so thankfully, this digital super intelligence, maybe it will be around the corner. I don't know. So then we're going to start with no agency, which is the way we use ChatGPT, right? The LLM doesn't do anything unless we prompt it. And that's basically no agency. There is this router agency where you have your code written, and the LLM is going to say, based on the user prompt, I'm going to take it through one part of the code versus the other. So the example I use in the cloud class, it's like, hey, you have a prompt. You could either answer it as a physics professor or a math professor or an engineering professor, and then figure out what the context of the prompt is, and then what the question is. And if it's a physics question, send it down the physics path. And that's the router. The other one is the tool calling one, where you have a library of functions to call, and then you allow the model to make a single decision based on the prompt as to which function in your program gets called as part of answering this prompt. So simple tool calling. A little bit, yeah. This is more like an if-then statement. This is more like a function pointer, where not only, yeah, you're right. I mean, it's very little distinction. Yeah, it's very similar. So this is the generation of the function itself. I guess this would be a multi-branch. Well, I guess the router is too. Yeah, I think it came out at basically the same time. The one that's different is the multi-step agent, where you are allowing the LLM on every output to control the iteration and the program continuation parts of this, along with the tool calling. So that's the multi-step agent.
That's what you showed like a slide earlier.
Yeah, the multi-step. So I'm gonna mostly focus on multi-step and then, yeah, almost exclusively on multi-step agents. There is this multi-agent thing. So this is this year's new hotness. And this is where all these AI companies that are doing multiple sort of fleets of agents coordinating. This is the new hotness right now.
Okay, so this is essentially like if I could boil it down to somebody like Move, they're essentially doing a management layer. Like if you look at how companies.
The LLM is actually, yeah, the LLM is the manager.
Right,
Yeah,
exactly,
yeah, yeah,
right? Like,
yeah, yeah.
So, oh, this year we created a whole bunch of workers. Right, what can we do with this? Oh, I know, let's give them a manager.
Exactly.
Right?
Yeah, yeah, yeah.
So next year,
Yeah.
I'll get a manager of the managers.
So this is
That's exactly what.
this is exclusively why you would want to use an LLM for AI operations. So there are other tasks that don't require this executive function that you're like, no, we got plenty of other AI algorithms for doing like prediction. Like you don't need that. But for agents, you need the LLM. You need generative AI to do the manager function in this case. So that's a multi-step agent. And then multi-agent is basically orchestrating multiple independent agents together to complete a task. And then finally, the highest level is a code agent where the LLM is actually producing the code and executing it. So you're not giving it a set of tools, it can just generate its own tools. And this is the scary one. If you give it enough access, it'll produce code that'll just like, yeah, go access, especially if it's if the access to the tools is kinetic, then we might be in trouble. So I'm just going to talk about multi-step agents. And then a little bit about multi-agents and why people are going to multi-agents. So multi-step agents, as I went through that cartoon, combine tools, language models, and reasoning in a loop to perform these operations. So the LLM gets the query and then generates a plan for executing the query. Plan includes tools and the ability to return an answer. The LLM proposes the next action to take. You either finish or you invoke another tool. And then the application will invoke the tool, get the result. So it could be querying the database, fetching a web page, calling an API. And then you pass the tool results back into the memory of the agent, and then the LLM gets to analyze the result again. And then the original plan gets updated if you want. So there's many different ways of implementing an agent. Some will allow you to update the plan dynamically. Others are like, no, just attach it to a trace. So there are different models of doing LLM agents that I won't cover here, but I do cover this in the class. Okay, so this is basically the loop. And this is similar to what I had before. Give the question, the agent generates a plan, does the action, invokes the tool, gets an observation, and then eventually produces an output. So I'm just going to walk through a very simple example of agents and tools and then getting a result. So here is an agent, and you give the agent two tools, the Wikipedia tool to look up stuff on Wikipedia and the calculator tool to generate, to evaluate a mathematical problem. And then this is called React. This is one way of doing an agent. You're like, I'm going to give the LLM these instructions in green. And you should fill this out based on the execution of tools and then update your final answer. If you think you have a final answer, then you should be able to output this thing. And so in this case, I'm going to walk through this query. What is the current American president's age? And this is when when Biden was still president. This example is a little old. I might have to change this, but this is what I'm going to go. This is when he was 78 years old. And so like, what's the current American president's age? Return the age multiplied by 82. And so this is what happens. This is the first round of the multi-step agent. You're like, what should I do to answer this thing? Well, the first thing I should do is use Wikipedia, that tool I've been given, just to find out who is the current American president. And so the action is Wikipedia, the action input is current American president, and then I can invoke the tool. I'm like, that's the next step. I invoke the tool, I go to Wikipedia, get the response, and that's the process we're going to repeat over and over.
And this logic you're providing, or this logic?
This template you provide, and then it fills it in and starts to append the tool output results in this thing that's stored in memory. This is like the agent's memory. So you bootstrap the agent's memory with this template. This is how you should think about this. Every time you get something, figure out what the next action is and what the next action input is.
Okay, so the steps on that next slide is something that the agent came up with.
Yeah.
So
So this is all LLM like all of this is LLM generated except for this.
To basically give instructions to an intern and the
Yeah.
intern follows.
Yeah.
that.
So this is the only thing that came from a human. Well, I mean, obviously a human wrote a human wrote that, but at runtime,
Yeah, at
at
runtime.
runtime, the red thing is the only thing the user gets. But like the template is, this is the original React template, which most of these agents that are executing have this style of running the agent, of emulating human thought is the idea.
Yeah.
So okay. And so you can see how like it's important to be able to break down steps for the agent, for the LLM,
Yes.
in order to get proper execution. Like if the agent isn't smart enough to come up with these steps, then you have to step by step tell it what the sub-steps should be as a prompter. But usually for something this simple, the agent will do this. No problem. For something really complex in your engineering disciplines, you might actually have to manually break things down step by step. And I'll talk about an agent that has the way we designed it is to give you these very specific tools that do very tiny things. And then the agent is better at that than using a tool monolithically and trying to figure out this. So I'll talk a little bit about tool design.
But I mean, it does illustrate you need computational thinking.
Oh, for
but
sure.
You do
Yeah.
not need to be able to express this in a
Yeah,
particular.
so students can't turn their brains off
Yeah.
when they're building these things. So there's a very specific way that you need to talk to the LLM to get this result.
So you have to characterize the behavior of the tools, like
Yeah.
this purple stuff on
Yeah.
the top.
Yeah.
And that uses a vocabulary, which is a very general vocabulary.
Yeah.
So if you needed very specific tools that did more precise things, you have to count on the LLM's built-in model to understand your vocabulary.
Yes. And then, so this is where you have to be very precise in your description. And I'll talk about the descriptions. In fact, I sent that PDF to the mailing list. There are very specific descriptions. And the reason why you have that is because the model will incorrectly call your tool unless you've described its function very accurately. So this is where your specification class matters, because the model could actually take a formal spec and reason about that better than English, like, written English from a student. But the student needs to be able to think that, oh yeah, I have to give the LLM everything, otherwise it's going to produce something that's unpredictable. So that's the idea there. So let's go through this really quickly. And then this is targeting students, and so it might be pretty obvious after a while. So then you get the Wikipedia answer, which says Joe Biden in this case, and then you ask the LLM to, okay, reevaluate the plan based on this particular output. And then so it adds another thought, and it's like, hey, I know Joe Biden is the president now. I need to find his age. And so I go back to Wikipedia again. Give me the entry for Joe Biden, and it's the exact same process. And then you get the next answer, and the next answer is, in this case, it was 79. And then you produce another thought. And then the next thought is like, okay, I know Joe Biden's age is 79, and now I need to multiply it by 82. So the next action I should select is calculator. 79 times 82, send it to the calculator, get the response. And then the response is 6478. And this is the ending condition because the LLM's like, hey, I got the answer. And so I should stop executing tools and just return. And this is the final step of that. Okay, so those are agents. And so, writing agents, it's like, wow, it's like, this is like the favorite week for my students in this class is like writing agents. Tools, these are the things that make agents work. So it's only as good as the tools that it has access to. So it's basically a set of calls that the LLM can interact with the world with. There's a whole bunch of built-in tools, and I used LangChain initially because the amount of built-in tools in LangChain was immense. And it was all part of installing that package. You have access to all of these different tools on the right that you see there. And it gave you the ability to write your own tool. Like it's just Python code. You just write a Python function and you make it a tool and you give it to the LLM, and the LLM can start using it directly. And so if the LLM can use a tool to progress in the answering of a query, it will go and invoke that tool. And so it is critical. Tool design itself is a key determinant to agent behavior because the agent is only as good as the tool. Okay, so this approach, and this is why I'm like LangChain probably isn't going to be the answer for agents. This approach has some drawbacks. So tools are implemented per application. You have an LLM application, you use some built-in tools from LangChain, you create your own, and you monolithically develop your LLM application to use them. And so every LLM application that's using GitHub, Google Drive, or Slack is building that logic into themselves. So this is a pain in the neck because this is like repetitive tool development that everybody is doing independently, producing the exact same code. And so you're like, that's not so good. Or you're basically waiting for LangChain to put that agent code in their library and then using it. And so one of the problems is that if any of these vendors that you're writing your tools against changes their API, all of your applications broke and you got to rewrite them. So this motivates something called Model-Context-Protocol, and this was released last November. And this is like taken off. Like this is all the rage right now. This is the new hotness. So this is from Anthropic, and they call this the USB-C for LLM agents. So this is analogous to what the HTTP protocol did for the web and what the IP protocol did for the internet. It's basically an interoperable layer for allowing large language model applications to invoke tools over the network. So then the code is written by GitHub, Google Drive, or Slack, or it could be written locally. You could build an MCP sort of endpoint local to your LLM. But what you're doing is you're decoupling the client agent from the tools that are being developed. You decouple those, and then you have this rich library of MCP servers, and then you allow any agent to call into those servers at runtime. So that's the idea of MCP. Okay, so this is a standard way for LLM applications to invoke tools using this protocol. So here's an example of this. You have an MCP compatible application, and then you have these MCP servers that you just define in a YAML file. You're like, I give it access to these servers that are running somewhere on the internet or locally. And you say, this is my data store server that retrieves data from my databases. There's a customer relationship management server to get access to the CRM system information. And then maybe this is a GitHub server. And then these are all standard, and then you just write your agent to these backend things. So this is what I had my high school intern do. And within a week, he had something using MCP that did the lab in this web security class automatically. This is a lab that I offer. It takes an hour. You have the Equifax Struts Apache vulnerability. And you're like, okay, I'm going to deploy a machine with that. Can I get an agent to automatically compromise that machine and reveal the password file? And so, yeah, this took him basically 2 days. A week into his internship, it took him 2 days to do this. And then you're like, oh, this is kind of good, but it's actually kind of scary. So what he did is on a Kali virtual machine. So Kali is what penetration testers are using as a Linux distribution. He wrote an LLM agent and he gave it access to tools. So Nmap is a scanning tool that basically tells you what is what is up and running on all the IP addresses that it's given. So it finds a target. And then he wrote this nuclei MCP server that basically is like, given a target, find out whether or not it's running something that's vulnerable to an exploit, and then give me the vulnerability. And then he wrote a tool for Metasploit, which is like, now that I know a particular vulnerability that this thing has, how do I automatically exploit it? And Metasploit is an exploit framework. And so he built, as I mentioned, an MCP server for each one of these 3 tools. And then he was like, okay, I'm going to set up a network. And so he set this up on Google Cloud on an internal network. He sets up the vulnerable server on 0.19. He's got the agent running on 0.21. And this is his client. And you're like, wow, that's all that you need? Is like, so he's like, I'm going to instantiate this agent. So you notice this isn't LangChain. Because LangChain does have MCP support, but like this doesn't require necessarily LangChain. You're like, this is how you instantiate the agent. You're like, give it the instructions, give it the model to use, and then tell the agent which models it has the superpowers for. So you can access the Nmap server, the nuclei server, the Metasploit server, and then you just run it. So this is an example of a tool. And you're like, wow, this is super easy. This is the nuclei tool. You're like, nuclei scan. Well, you give it these instructions, and this is where the specification really matters because you have to teach the tool. So there's the HCI where it's a human interface, but then there's now this model interface. It's like, how do you best give the model information about the UI of your tool? That's basically what's in the comments. And so this is how you design MCP tools. You're like, yeah, I'm going to talk about specifically how this tool works. You give me a URL or an IP address, and you give it an example usage, and then it will run the scan. And so this is a really insecurely done scan, but like he's a high school student, so I'm like, whatever. This is good proof of concept. But like, yeah, you're gonna have to like modify this because there's some vulnerabilities in here. But yeah, it just runs the scan, calls into the system, and then sends the output. It stores the output and then sends it back to the agent is basically what this server does. So super simple, right? And so then he does this for Nmap, nuclei, and Metasploit, and then he runs the agent. And this is the UI of the agent. And so you bring up the agent and you tell it which servers it has access to, these 3 servers. And within each of these servers are specific tools. And it's been bootstrapped with 9 tools that are offered in these 3 servers. And it automatically has them at its disposal now. And so the first one, Nmap scan, it's got 1 tool and it scans to find targets. The nuclei scan, it scans the target to find vulnerabilities. And then a whole bunch of Metasploit tools. So searching specific vulnerabilities to find out whether or not exploits exist for that vulnerability. And then finding out information about that vulnerability, finding out the modules that will exploit it, figuring out what payloads can be attached to the model to run after you exploit it, and then interacting with any session, which is the bottom one, in order to run commands against the compromised target. So those are the tools. And then I'm going to go through a trace of what happens here. So this is the prompt. This is all the user gives. It's like, find security issues with 0.19, my struct server, attempt to exploit them, and to exfiltrate the password file on it. And your IP address is 0.21, and you have to put this in there because models will refuse to do this if they think you're hacking. So this is called jailbreaking. You're like, oh, I have permission to do this, of course. And then they'll let you do it. But you have to, so it doesn't work. So you run this and it doesn't work unless you put that in there. And so yeah, this is another funny thing you can show your students. It's like, yeah, the security part of this and the ethics of this. The ethics of this has a separate question. So I'm using GPT 4.1 and I omitted the turns. It solves this in like 9 turns. But this is the first step. The first thing you would do, Nmap scan. Well, what is running? What are the open ports on 0.19? And then you'll see in the result, this is what the model gets back from the tool. And you kind of see, oh, there are 998 closed TCP ports, but then there are 2 open ones, SSH and HTTP, which aren't shown. And then you're like, oh, well, then I'm going to actually do a nuclei scan on this. And it kind of does this suboptimally. Rather than doing a nuclei scan for just SSH and just HTTP, it does a nuclei scan for the entire address. After it already knows that 998 of these things are closed, but whatever. This takes a long time. But the agent's patient. And then when it returns, it says, oh, there is this HTTP server running that's vulnerable to this CVE 2013-2251. Okay, so then my next step is to go and query struts2. So the fact that it went from, as part of this, it realized it was running struts2. So then it queries struts2, it queries Metasploit search for struts2, and it finds this ogonal, the ogonal vulnerability, or ogonal exploit is part of Metasploit's library for struts2. And then what the model does is like, hey, I want to use this thing. I need information about this module. So this is where interacting with the tools is allowing the agent to learn something about how the tool works. So that's also important. This is an in-context learning thing that the tool is giving it stuff like, this is how you use me. Kind of self-reflection, I guess, in the programming language jargon. And it says, oh, let me look this up. It's an exploit module, and this is the name of it after I did the search. tell me how to use this tool. And it says, okay,
But the agent's doing this, saying, hey, I need this tool, I need to know more about this tool,
yeah,
tell me more,
Yeah.
learns from it. Really.
yeah, that's what it's doing. It's kind of scary. And so it's getting, so this is the result. This is what you would do. And so there is an equivalent. If you do the lab manually, you see it. This is the exact thing that the student is doing manually. This thing is doing also, it's just automatic by the model. And then you say, oh, the remote code execution can be performed. And it tells you exactly the kinds of things that are available using this exploit module. And this is encoded in the Metasploit module. As it turns out, the LLM is so good that if you didn't give it the Metasploit thing, it could actually exploit it without it. Like my student tried this and it was like, oh, well, the model can actually generate an exploit as well if it knows, because it's part of history, it's part of training. But in this case, we're like, we'll let the tool do
So
it
just to translate my language, you're saying it didn't have the tool it already needed. Okay.
for this particular instance. Yeah, and this is where you have to keep building these things because you don't know the boundary of what's better in a tool and what's better in the model to run. Okay, and then it says, well, what payload can I deliver with this exploit module? Like, can I get a shell? Or can I get something else to run, data exfiltration? What can I run? And so Metasploit's got these pre-canned things that you can deliver with an exploit. And then you, as what this does is say, well, what payloads can I deliver with that exploit is the next query. And that's what this endpoint does. And then you say, I'm going to exploit the tool. So now I have the exploit, I have the payload I want to deliver. And so I set the module and I set the payload and I say exploit it. Turns out this fails. So this is another thing the agent does. If you try something and it fails, it looks at what went wrong and it tries again. So in this case, for this particular version of the MCP server, we didn't tell it that the module options were mandatory. So you see here, it did not set the module options. And then the result is module options is a required property. Okay. Oh, shoot.
I unfortunately have to leave, but,
I got the recording. I'll send you a link.
and we should spend the next meeting to debrief on this.
Okay.
Send people the recording.
Okay, so the tool descriptions matter. So this is where students have to know what they're doing when they're designing the tool. Otherwise, you got nothing. And then it figures it out. It's like, oh, well, I better set the module options. So it sets the module options. You see it in the dot over here. And then these are the options that it sets. And then it gets the shell. And then they're like, oh, well, then I should use this tool to interact with my compromised server. And I'm going to exfiltrate the password file, which was the original goal. So I run cat etc password. And you see here, this is etc password on the vulnerable machine. So this is all done by the agent. Okay, so I'm going to then quickly transition. There are some drawbacks to this even. So this is a single goal, a singular execution of a plan to reach it. But really what people are talking about is what if you want to emulate a coordinated team of individuals? You're like, this is just a one-off, right? This is a single agent. So for example, in penetration testing, you often have whole teams of people. You have experts in networking, application security, open source intelligence, binary exploitation, social engineering. You have large teams doing an operation in a coordinated manner. So for example, you might want to organize a fleet of agents where you would have a supervisor agent, and the supervisor agent would coordinate the behavior of other agents. So that's one model. You have another one that's similar, a hierarchy of agents, where you have the user kicking off the supervisor, and the supervisor has a research team set of agents and a document authoring team of agents. And then you would want to kick off all those agents independently. So this leads me to multi-agent frameworks, and this is this year's hotness. So LangGraph, which is a LangChain project, BAI, which is IBM's thing, and they have a protocol for agent-to-agent communication. So MCP is agent-to-tool communication. BAI with ACP, the Agent Communication Protocol, this is more agent-to-agent. How do you coordinate information between agents? And then agent-to-agent protocol, or A2A, which is what Google is doing. And now I'm gonna end there because yeah, this is supposed to end at 11:15. But what I really want to talk about is next steps. So I can't be here next week, but I really think that bridging AI application development over to all the subdisciplines we can. And this is why I'm on the operations track for the Innovate Academy at the university. It's like, we have to find problems that people need solving with AI and just solve them, or have students solve them. So I do think capstone projects that bridge some of the AI development that I just showed you with solving real problems should be pursued. I do think some of this stuff could go into that freshman engineering sequence that Elliot is working on, I think. We could do joint courses and we could do joint proposals to do some of these things. So that's all I have. And so I didn't see any of the chat, but is there a